Welcome to Python Basics with EJD. This is the third video, I think, in the series about object-oriented programming. And here we'll be talking about encapsulation and data protection in object-oriented programming. So we have encapsulation and data protection in OOP. And the goal is to understand how to properly secure and manage data in Python classes using encapsulation, access control, and property decorators and validation. So first of all, let's talk about encapsulation. What is it really about? Object-oriented programming, of course, that principle of hiding details of an object while exposing controlled access. That is the encapsulation. It is the OOP principle of hiding internal details of an object while exposing controlled access. Of course, you know that there are situations where you just need to you don't need to expose every information. You just want to show some aspect of a particular thing. So groups data or attributes and methods or functions together inside a class. So encapsulation actually gets to group data and methods together inside a class. Of course, we know data and methods are actually attributes and functions. Just like we keep saying, if you have a car, the car can be red, it can be Jeep, it can be all that. And then it also has functions like uh like driving or refueling and things like that. So an analogy is of a vending machine, for instance. You press buttons, these are the methods, but you don't directly control how it handles money or items. Okay, so those are internal data. So those internal parts, they are not your business per se, and that is exactly what encapsulation does for you. It not only makes you see what is happening, what you need to see, right? Just when you are using an automated teller machine, for instance, yours is to get there, insert your card, put your PIN, and whatever transaction goes on inside the machine, you don't get to see. Those are the internal data going on, internal activities that is. So why does encapsulation matter, right? Why encapsulation matters? First of all, security. It helps to protect sensitive data like PINs, passwords, medical records. And then encapsulation helps consistency because it prevents invalid value. So if you, for instance, if you withdraw all your money, I mean, number one, it ensures that you don't even get to withdraw more than what you have in the bank, right? And by the time you finish withdrawing, you can't withdraw to a point that you now have negative balance or something like that. Then it's also good for abstraction. So user focuses on what it does, not how it does it. So if you go to a vending machine, you just want to dispense maybe a drink or so, you don't care how you get the drink. All you care about is that you get your drink. And then encapsulation matters because of maintainability, because it is easier to update code without breaking usage. So let's talk about some access modifiers in Python. So Python does not have strict public, private, or protected keywords like Java and C++. Instead, it uses naming conventions. So it's all about the naming. That is what will give you what you need. In all, like I said in the first video, object-oriented programming is not limited to only Python. It's a general programming construct, but then we can also apply it in Python programming because it is a multi-paradigm programming language. So instead of other programming languages like Java and C++ that have strict public, private, and protected keywords, in Python, it just the naming convention, how you name your class is what determines how it goes. So you have the public, which is default. In that case, the information is accessible everywhere. For instance, you have class example, and then you define, you initialize, right? And then you have self.value equals 10. So this information is public now. So this is good. The usage is for object value, for instance. Imagine if let me try. So if I have something like this, okay, I have the class, then open and close, and we just need the value, okay? So it just prints that 10 for me because it's available to the public, okay? So this is how you use it. So the object, that example dot value, that's how you use it. That's what that actually means. Because first of all, if you just run it, okay, and then if I do alternate enter, it creates another cell. Or maybe I want the cell to come after, I want the cell to just to come after that usage method. So I can create the code cell after that. So I just come here. So I call the class, the object, then the value, and it gives me that 10, basically. So when you come here, for instance, we go to the protected. So you see the public one is default. That's how you define a class normally. But for the protected, you have a single underscore before the variable, right? So protected into underscore variable. So that is internal use, and it's discouraged to access outside. So it is for internal use only, right? So here you say class example. You define the class example, initialize, and then self. Now you see here we had self.value directly. But when we come here, you don't just have the value, it's self underscore protected. So this is the naming convention here. First one is normal. Here you have single underscore, and then what you are going to get is internal use only. That's the job the class is doing. And to use the usage is about you know object underscore protected, and that still works, but it is discouraged. So in this case, now we run this first of all. I think I ran that before, right? Control enter, then I come here and I create a cell to help me run another code. So here now I have example. So I have example. So this is how we can use it. Example dot protected. So this has given it to us like that. I just use tab, and if you run that, then it just says internal use only. So if you remove this now, it doesn't work because the naming convention requires that you have a single underscore like that. So that is for protected. So there's public, there's protected, and then there's something that is absolutely private. So here you have the name is you have name mangling, and that leads to class name variable. So double underscore is what happens here, and it is harder to access from outside. Okay. So in this case now, you have class example. Then after the initialization, you now have self dot double underscore. So you see underscore. So this is like first underscore, second underscore before the word secret itself. So this is totally hidden, right? This is hidden. And of course, you need to run that. Then after running it, then you can, after running that, right? Then you can create another cell to implement the code. So it says object dot underscore example double underscore secret. So before it would be the example and then protected or whatever. But here now even the example requires the class underscore class name double underscore variable. So in this case now we have in this case now it's object, right? So we have object dot, oh, what do we do? Oh, underscore example, underscore example, double underscore secrets. Okay. And then we have this. Oh, it's not defined. Okay. Are we supposed to say object dots? Would that work? I don't think so. Okay. So what we've been doing before is object dot double underscore. Okay, I guess something is wrong here. So, okay. So it's not even recommended, right? It's actually not recommended in the first place. So what this is supposed to be hidden, you don't get to see anything here at all. So how do we run this now? Let's see. Okay, so we now need to add another function. Okay, so that is not added here, so it's okay. So let's leave that alone. Let's leave that alone. Okay. So this can go. Yeah. So those are the three access modifiers in Python. We have public, protected, and private. Now, let's talk about encapsulation in practice. So this is about securing data, right? Hiding the part of data, showing you the part of data of the process you need and hiding the part that is not required by you. So encapsulation in practice, we secure data by using private attributes. So here we have double underscore attributes. Then we have getter methods, which is read safely. We have setter methods, which is validate before updating. We have property decorators, which are Pythonic control. So we can take this one after the other and look at them. So let's start with property decorators, where you have things like at property and at setter. So here, imagine you define a class called student and you initialize with two attributes, name and age. So because of the encapsulation thing, you now have double underscore before each variable, before each attribute. So you have self dot double underscore name, right? And then and equals name instead of just saying self dot name equals name. Here you have self dot on double underscore age equals age, and then you have at property. So like we said, at property is good for Pythonic control. So at property, you now define a function, age self, that is a getter in that case now. So you have return self double underscore age. So you want to return the age in that case. Then for age setter now, so you define age self, you take the value of the age, that's setter with validation now. So if value is greater than or equal to 0, then self dot age is equal to whatever value you supply. So else you now have print age cannot be negative, right? So if you run this now, you don't get anything. So let's see how do we obtain result from this. Okay. Let me see if I bring this now. So you see, property makes a method behave like an attribute, while property that setter controls assignment with validation. So we bring this in now, and we have something like this. Let's see, we can get some suggestions. So we have that student right there, and okay, okay, maybe that's just for explanation. Okay. Or we can actually use the help of this now. Uh, run the class. Say run the class. Okay, let's see what that does. Okay, I think it gives a kind of demonstration. Okay, first of all, nice. So it tells us that okay, I forgot to run that, right? That's why it's still showing that color. Yeah, accept and run. Good. Yeah, that's it. So here now, we now have so student, we have student at least 20 because those are the two attributes, name and age, right? So you have student at least 20, then you print initial age of the student, accessing the property now. If you now say student.age is 21, that's you using the setter. So if you now print updated age then student.age is -5, testing validation. So here now you see initial age is 20, updated it becomes 21. Age cannot be negative because if you say student age is -5, you want to test the validation. So it prints this information that age cannot be negative, right? So it tells you age cannot be negative. Then age after invalid attempt will now be 21. That's the updated age. So after the invalid attempt. So it means I can go back here. I still feel we should be able to run this, right? Let me do the code thing and we say run the class, right? Run the class. That's the example class this time around. So that's one beautiful thing about Google Colab. So you have AI working with you real time. Okay. So what does that give? Where were we? Aha, yes. Finally, we got something out of that. Nice. So for us to print this hidden out, so accessing the private attribute using name mangling. So we need name mangling. So I think that's where the mangling thing came. So first of all, okay, the object itself. So we want to print example, that's the class dot underscore example double underscore secret. That's the only way we can now get this. So if we run this now, we get this hidden thing. So that's how to do it. So we have example open and close bracket dot underscore. So this object will still be that same example like before. But even without the print, can't it work? I want to try that out. Without the print, we should still be able to, yeah, it's fine. You're able to get a result. Except that it is actually string, but which is fine too. But that's what we've been doing. So it can follow the whole object dot blah 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 that we've been working with. So if you use Google Colab, you have the extra advantage that you can use AI in case you need to get clarity. So controlled access now prevents attributes from being modified directly. All right. So example, setting age to -10 is blocked by validation. Just like when we set age here to be -5, it says age cannot be negative, and it ensures data integrity across the program. So encapsulation ensures controlled access. Then when we talk about validation before setting values, example of validations like a bank account, you cannot withdraw more than balance. If you have $1,250, you cannot withdraw more than that, right? So student record, like GPA must be between 0.0 and 4.0, depending on the situation you're in. Maybe if you're in the US, that's 0 to 0.4. In most parts of Nigeria, it's 0 to 4 to 5. Okay, so whatever the context is, so you set validation before setting val. So you have to think about the restrictions. For user profile, email must follow valid formats. For instance, you cannot be having email without the @ Then you have security print must be exactly 4 digits, depending on the kind of card you're using. So to close this out, we have a mini project as like we've been having under every video under object-oriented programming. So let's look at a bank account class, for instance. So the requirements want to keep account number and balance private because it's your personal information. Then want to allow for safe deposits and withdrawals. We don't want to, you can deposit as much as you want, but you cannot withdraw beyond what you have. Then you want to also validate transactions and expose balance through a property. So let's see this now. Okay, let's go step by step, right? So we create the class called bank accounts, and we initialize, we have two attributes, account number and balance. So default balance is 0. If there's no money in the account, of course, default balance will be 0. So we can use default here. Then we make this a private thing, so we have self double underscore account underscore number. So that's equal to account number. So that means that this account number cannot be accessed directly because it is private. Then if you add single underscore, that will be I think what did we call that the other time? We had public, we had protected, exactly. Single underscore would mean protected. That's what that is. So we have self dot double underscore balance equals balance. That's also private. Then at property, that thing we did before. So you define the balance, and then that's read only balance property. Then return self dot double underscore balance. Then for define, you also want to define deposit self amount. So the deposit has just one attribute, attribute, that's amount. So if amount is greater than 0, so you can then say self dot balance is plus equals amount. So the amount, of course, cannot be less than 0 for sure, because that's the minimum you can have in the account at any point in time. So if you now deposit this amount now, so the self balance that was secret will now be incremented by the amount you deposit. Okay, so the whatever you have there will be increased by the amount you deposit as expected, so that, okay, I want to see all of this at once. Let me see how far I can do. Yeah. So here now, you now print, so you have this check mark, deposited amount. New balance will be self.balance. So it will print that for you. And else it will print deposit must be positive. So if you try to deposit a negative amount, that won't work. So it will just say deposit must be positive, so we can know that something is wrong. Then you also have the withdraw. So define withdraw self amount. If amount is less than or equal to 0, so withdrawal must be greater than 0. Okay, so you cannot withdraw when you have less than or equal to 0. So that's the first thing you get. Else, if amount is greater than the self balance, okay, if amount is greater than self balance, then it will print insufficient fund. That's what you get exactly from the ATM. So if you are trying to withdraw more than what you have in the account, insufficient funds. So once if these two conditions are not there, like you have more than 0, and then you have the amount you want to withdraw is bigger than the balance, then else finally it will now, so your self balance, which this private self balance now will be reduced by the amount you are withdrawing, and then the self balance now becomes whatever is left. So it cannot print withdrew amount, and then new balance is that self balance. So if I run this now, of course, we have not told it to give us any outputs. So, but then we have the demo usage here now. So you can now come here and say bank account. So the two attributes, you have account number and balance. So it means your account number is 12345 and the balance is $500, so to speak. And then if you do account the deposit, if you deposit 200, it will run that thing and then it will add 200 to your deposit. So deposited 200, new balance is 700. That's what you're expected to get by the time we run this. Then account dot withdraw 1,000. Now you have 700. So it tells you insufficient funds, because you have 700, but you want to withdraw 1,000. And if you do account or withdraw 300, then that works. Withdraw 300, new balance will be 700 minus 300, and that'll be 4. Then print account dot balance, that'll be 400, and that will give you safe access. So, but then if you do print account dot double underscore balance, it will give you error because attribute is private, so you cannot just print like that. So if I run this now, it will give us all those results. So this is supposed to be for safe access, but since the account is private, you can't see it, right? So you have deposited 200. I mean, just like what we expected here. Then, because you're trying to withdraw 1,000 here to tell you insufficient funds, you try to withdraw 300. Good. So withdraw 300, new balance is 400. And then for this balance now, safe access, so it gives it to you. So, but for this now, you cannot print something that is private. You can't print it directly like that. Okay. So we have that. And that is why it gives you an error. Say bank account object has no attributes, double underscore balance. So you won't be able to print like that. So the key takeaways here is that encapsulation helps in hiding complexity and security data, and it uses naming conventions. You have the public, where you don't have to worry, you just do the regular class naming, and then if you have the protected, which is underscore the variable, whatever variable you're calling. Then if you want it private, you have double underscore the variable for protection levels. Then you can use that property and at setter for Pythonic access control. Then you always validate data before storing it. Example, the bank account project applies encapsulation in real world context, right? So with that, we come to the end of this video. Let me know how helpful this video is for you. And if there's something you'd like me to try out, feel very free to let me know. If you have subscribed already, thank you so much for that. If you haven't subscribed, of course, you'll be missing a lot. So go ahead and subscribe. Subscribe and hit the notification bell so you can always get alerted each time a new video is released. And of course, you can take it a step further, click on join, and you see 3 levels of membership with some special privileges attached. So that gives you some exclusive rights as a member of the channel. Ultimately, don't forget to like, share, comment, so that more people can have access to the great content we have going on here. Till I come your way again, keep doing Python right. Bye.